Hi guys, and welcome back to another Unity tutorial. This is the second video in the beginner series in which we will be making a 2D apple picker game. Today we will cover making the basket which the player will control and keeping track of the score. If you're new here, I'm an indie game developer and I post tutorials like this as well as devlogs documenting my progress with my games, so if any of that sounds interesting to you, please consider subscribing. If you find this video helpful, smash that like button because it shows me that someone is getting value out of my work. Without further ado, let's get started. The first thing we're going to do is right-click in the hierarchy, go to 2D Object and select the sprite. I'll hit F2 to rename it and call this the basket base. For the basket's graphics, we're just going to use a white rectangle for now, so if you're on Windows, open up Paint, select Resize in the toolbar, Pixels, make sure to uncheck Maintain Aspect Ratio, and then choose 100 pixels by 100 pixels and hit OK. I'm going to hit Ctrl S to save this, and then go to a folder within your project and save it there. If you're on a Mac, you can go online and search up for white square. Go to Images and simply download any of these, they will all work fine. Now, back in the basket base, I'm going to go to the sprite and select this circle with the dot. Now I will select the white square sprite that we just made, then set its position to 0 on the X, -4 on the Y, and 0 on the Z. I'll also set its scale to 2 on the X, 0.2 on the Y, and 1 on the Z. With that done, I'll click on the basket base, then press Ctrl D to duplicate it, and call this basket left. I'll set its scale to 0.2 on the X, 1 on the Y, and 1 on the Z, then its position to -1.1 on the X, -3.6 on the Y, and 0 on the Z. These are just some values that I have determined beforehand, but if you want to, you could also experiment to find what values work for you. I'll click on the basket left and hit Ctrl D once again to duplicate it, F2 to rename, and call it basket right. I'll set its position on the X to +1.1, and that is the only difference that we'll have to make. Now I'm going to go to the hierarchy, right-click, and create empty. I'll call this the basket, and then I'll right-click on the transform and hit reset. Next, I'll select the basket base, then shift and click on basket right to select them all, then drag and drop them onto the basket, making them children of the basket. This means that if I move the basket object, all three of them will move. With the basic graphics done, we need to create a script so that the player can control the basket. To do this, I'll right-click on the scripts, create C# script, and I'll call this basket. Give it a moment to compile, and once that's done, double-click to open it up in Visual Studio. Now we want the basket to move on the x-axis as I'm demonstrating here, and the y and z position values should always be 0. The way that we're going to control the basket is using the mouse pointer, so it will simply follow the mouse's x position. To do this, I'll go back to the script and type void update. This may already be present in your script as a default, and then inside it, we'll type vector3 mouse position is equal to camera.main.screen to world point, and then inside parentheses input dot mouse position, and then end with a semicolon. Now this looks like a lot, but all it's saying is take the mouse position, which is given by input, and that is in a 2D space, and convert that to a world point, so in 3D space, using our current camera. If this is a bit confusing to you, don't worry, as these functions and syntax will become normal to you after using Unity for some time. Next, I'm going to type float mouse x to declare a new floating point variable, which, if you remember, is just a decimal number, is equal to mouse position dot X. And looks like I've spelt mouse position incorrectly up above, so I'll just fix that. And there we go. So remember, a vector 3 is a variable which contains 3 floating point numbers, which are x, y, and z. So if I take the x value of the vector 3, that will give me the x position of the mouse. Now I can simply say transform.position to get a reference to the position of this object, which remember is the basket, and we'll set that equal to a new vector 3 with mouse x on the x-axis, 0 on the y-axis, and 0 on the z-axis like we discussed earlier. Now if we return back to the editor, I can hit add component under the basket and search for the basket script that we just made. Hit enter, and now if I hit play, everything should be working. You can see that the basket follows the mouse, which is exactly what we want. However, it's still not collecting apples, so let's fix that next. To interact with the apples, we're going to need to add a collider to the basket. To do this, hit add component, then search for box, and then we can select boxed collider 2D. This green square in the scene that just appeared represents the box collider, and you can see that it's in the wrong position right now. Through experimentation, I've determined that the correct values for the offset and size should be -3.6 for the offset's y value and 2.4 for the size on the x. Now if I zoom into this, you will see that the green box surrounds the basket nicely. We will need to select this option is trigger in the inspector, and to show you why, I'll demonstrate what happens if it's not checked. As you can see, the basket is acting kind of like a platform for the apples, but the behavior that we are going for is for the apples to fall into the basket, not be stopped in thin air. So now if I select the is trigger option and hit play, you'll see that the apples are falling straight through it. It looks like there's no difference from earlier, but now what we could do is go into the script and detect when the apples fall into the basket. Later, if we want to, we could also make it so that the apples are collected in the basket rather than falling straight through. Another problem that I noticed was that if the mouse went out of the screen, the basket would follow. This is not something we want, so to fix that, let's go back to the script and then add under the float mouse x equals mouse position.x, mouse x is equal to mathf.clamp mouse x minus 7.5 f to declare that it's a float that we're talking about. Anytime that you use a decimal number, you have to include f after it, and then positive 7.5 f and end with a semicolon. What this is doing is clamping the variable mouse x to a value between -7.5 and +7.5, which I determined through experimentation to be the values we should use. Now back in the basket script, let's implement collecting apples. To do this, let's make some space, then type void onTrigger enter 2D since we're using 2D objects, and then you'll see that it auto-completed for me. Just to make sure that this is working, I'll type print collided and end it with a semicolon. This is just for debugging purposes so that I make sure that it's registering collisions before I go and implement the code. To test it, I'll just hit play. And as you can see in the console, we're getting messages that say collided. You'll also notice that the basket is being clamped to the edge of the screen and isn't coming out. Great. Let's go back into the script, and I'll just quickly explain what this function does. So this function is automatically called when a collider enters a trigger on this game object. We call things in the parentheses inputs. So in this case, other is an input, and its type is Collider 2D. Input types can be anything, such as integers and strings, but in this case, it is the collider that entered the trigger. In our game, the overlapping collider will be the collider from the apple. To keep track of the score, we need to have a score variable. We declare variables at the top, so I'll make some space and then type int score equals 0 to declare a variable called score, type of integer, which are just whole numbers, and setting its value to 0 to start the game. Under collided now, I'll type score equals score plus 1, which increments the score by 1. But actually, there's an easier way to type this. If you're setting a variable to itself plus another value, you can simply type the variable followed by plus equals the value. The score plus equals 1 is the same as writing score equals score plus 1. And in fact, if you're just adding 1, there's an even easier way to do this, which is just by typing score plus plus. And that's the simplest you can get, so I'm going to leave it at that. Now we also want to destroy the apple once it passes through the basket. So I'll go to a new line and type destroy, and then in parentheses we have to enter what we want to destroy, and that's going to be collision dot game object. Remember, collision is a reference to the collider on the apple, so we're getting the game object which collision belongs to, which is the apple, and destroying it. Now we can go back to the editor and hit play to test it out. We've got apples falling, and yes, we can see that they're being destroyed when we collect them. Collided is being printed in the console. And now, if I go to the basket script, you can see that we can't see the variable score here. But if I click on the three dots at the top and change the mode from normal to debug, we can see more information, including the score, which is currently 8, 9, and if I collect a few more apples, you'll see it keeps on going up. Great. But now we don't want to have to look at this to see our score, so I'm going to reset this back to normal. And next we're going to implement a UI for the user or the player to see. To do this, I'll right-click in the hierarchy, go to UI, and select Text. I'll press F2 to rename it and call this Score Text. Before we do anything, I'm going to click on the canvas and change its mode from constant pixel size to scale with screen size, and then choose a resolution. I'm going to go with 1280 by 720 for now. This essentially means that no matter how big the screen is, whether it looks like this or like this, the text will look the same on the display. We can see this in action if I click on the text and change its color to white to make it a bit more obvious. I'll increase its font size up to say 40 just for now, and then also increase its size just so that we can see it. You don't need to follow along with this part, this is just for demonstration purposes. You can see that it says new text over here. It's about the same size as the basket. And now if I press shift space to maximize the game view, the text remains the same size relative to the rest of the screen. If we hadn't changed the settings in the canvas, it would remain this size no matter how big the screen was. With that out of the way, I'm going to set the default text to score, space 0. I'll set its font size to 50. Color is already white, and then I'm going to scroll up in the inspector and select its anchor, which is currently center middle. I'm going to hold Alt and then select the top left anchor. With that done, I'll zoom out in the scene view so that we can see a bit more, and then drag it away from the corner just a little bit because I think it looks a bit nicer like that. We can also resize it from here, but this should be about fine. Now, we need to edit this score text somehow because it's not going to magically change itself. So I'll go back to the basket script, and at the top I'll say using Unity engine.ui. If we want to work with UI elements, this is just a line that you'll have to remember to include. Now, under the int score, I'll say public text score text. And then in the onTriggerEnter2D, after incrementing the score, which just means adding 1 to the score, I'll say score text dot text to reference the text component equals score colon space, and then using some funky syntax, we can say plus score to add on the value of the integer to the end of the text. Now, I'm also going to remove this print collided here because we don't need that anymore, then return back to the Unity editor. The last thing we have to do before hitting play is select our basket script, and you'll see that there is a score text option here. That's because we set the text to be public, meaning that it can be accessed from just about anywhere. If I return back to the editor, I can simply drag and drop our score text into that slot, and all should be working. So I'll hit play, and you can see that the score text is incrementing. If I stop the game, maximize the screen, and hit play again, you can see that the score text has retained its relative size, which is what we wanted. That's it for this tutorial. In the next one, we'll look at adding rotten apples which subtract points from the player, as well as keeping track of the high score. If you want to see more content like this, remember to hit like and subscribe, as it really motivates me to keep making more videos. Thanks for watching, and I'll see you in the next one.